Hi everybody, today we're going to talk about linear equations in one variable. A linear equation in one variable can be written in the form ax plus b equals 0. Here a and b are going to be real numbers and a is not going to be 0. We need to have a coefficient to our x term. Our variable doesn't have to be x, we can use y, s, t, whatever letter we want, but what we're looking for here is the power of our variable is only 1. What I want to emphasize here is this phrase can be written in the form. So just because something doesn't look like ax plus b equals 0 doesn't mean that it's not a linear equation. So today we're going to go through a ton of examples and I'm going to show you a lot of different ways that linear equations can be written. Let's also note here, when I'm talking about linear equations, it doesn't look like the y equals mx plus b that I think you usually think about when you think line. Are these still lines? Absolutely, but they're very particular kinds of lines. And we'll get into lines very soon, but I just want you to think only one variable for these particular equations, which is going to make it a little bit simpler to solve. As we're solving linear equations in one variable, our real goal is to isolate the variable. To do this, we can add, subtract, multiply, and divide both sides of the equation by any non-zero number. I just want you to be consistent. If you do something on the left, make sure you do that same something on the right. When the equation has a solution, we say it is consistent. This is also called a conditional equation. This means the equation is true for this particular value of the variable. So our condition for the equation to work is that we use this value. So let's take an example of a consistent equation. I have 3x plus 7 equals 9. So to isolate this x, I would move the 7. So let's say I subtract 7 from both sides. This says 3x is equal to 9 minus 7 is 2. I want to get rid of the 3, so I'm going to divide both sides by 3, and I get x is equal to 2 over 3. So what you see is I'm kind of always doing the opposite. When I had add 7, the opposite is subtract 7. When I had multiply by 3, the opposite is divide by 3. So I keep peeling away all these numbers to get the x all by itself. So this would be an example of a conditional equation. I have an answer, so that's consistent. The only time this equation is true is when x is equal to 2/3. So let's do another one. I have 4x minus 3 is 2x plus 11. Now this time I have x's on both sides of the equation. I also have constant terms on both sides of the equation. So let's say we start with this 3. Let's move the minus 3 to the right, so I'm going to add 3. Now I have 4x is equal to 2x plus 14. I want to move the 2x over to the left, so I'm going to subtract it. But notice I have to subtract from both sides. So 4x minus 2x is 2x. I still have my 14. So my last step is to divide by 2, and x is equal to 7. All right, this time I have x minus 5 is 2x minus x plus 4. So the left side, let's leave it alone, x minus 5. On the right side, I have this negative that needs to distribute to both the x and the 4. So I have 2x minus 4. This says x minus 5. 2x minus x is x minus 4. At this point, I've simplified the right side, so now I can move things back and forth. So let's say I move that 5 to the right. Now I have x is equal to x plus 1. Our problem comes when I try to move the x's together. So I move this x on the right over to the left, so I'm subtracting it. X minus x is 0, and on the right side I have 1. Now this is a problem. 0 is not equal to 1. So what this tells me is I have no solution. How I kind of read things like this when I get like a constant equals a constant, I say to myself, is that true or false? If it's false, I say there's no solution. What we call that is an inconsistent equation. And basically an inconsistent equation is just a false statement. It means there's no solutions to this inconsistent equation. So let's try a different example. 6x minus 3 is equal to 3 times 2x minus 1. So the left side looks good, 6x minus 3. The right side, again, I'm distributing. 3 times 2x is 6x. 3 times negative 1 is negative 3. Now, hopefully, right now, you can see that I have the same thing on the left and the right. I have 6x minus 3 is equal to 6x minus 3, which makes perfect sense, right? Something should always be equal to itself. If you decided, though, that you want to keep going, like, let's put the constants together. So I would have 6x, the 3's would cancel. I would have 6x, and the 3's would cancel. Then, usually we're trying to bring all the x's to the left, so let's subtract 6x from both sides. 6x minus 6x is 0. 6x minus 6x is 0. This is true, right? When I look at this, 0 is equal to 0. That's true, just like 6x minus 3 was equal to 6x minus 3. So this time we have a different thing that went on. We got to the end and we got 0 equals 0. So this we call an identity equation. An identity equation is true for all values of the variable. So any number I want to put into that equation, it's going to make it a true statement. Identity equations will have infinitely many solutions. So 3 things going on here. Consistent, we're thinking one solution. Inconsistent, no solutions. Identity, infinitely many. So for the rest of the time I'm going to spend today, we are just going to go over a bunch of different equations to make sure that I've covered different things that can happen when you're solving. So this one that says 8x plus 12 is equal to 3x plus 16. I think we know by now that we want to move all the number parts together. So the 12 cancels. I have 8x is equal to 3x. 16 minus 12 is 4. Then I think put the x's together. So let's subtract 3x. 8 minus 3, there's 5x, is equal to 4. I divide by 5, and x is equal to 4 over 5. It is perfectly okay that our answer is a fraction. Nothing wrong with that. If you wanted to check it, you could plug it back in and make sure the left side is equal to the right side. It kind of depends on how much time you have. Sometimes you're just trying to get through the problems and you don't have time to check. So let's look at one that starts as a rational. I have 9y plus 2 over 6 is equal to negative 3. Now, what I think with fractions is the easiest thing to do is really to get rid of them. So what I'm going to do to get rid of them is multiply both sides by 6. So as long as we're consistent, we can do whatever we want. The 6 cancels the fraction, so now the left is 9y plus 2. The right side, negative 3 times 6 is negative 18. Now it looks a lot better. I can subtract 2 from both sides. I get 9y is negative 20. And then divide by 9, I get y is negative 20 over 9. So once again, we got a fraction, and that's completely okay. What I would say with a fraction is put it in lowest terms. So if you can reduce it, reduce it. I probably wouldn't make it back into a mixed number. I wouldn't make it a decimal because it's not always going to have a good decimal representation. So I would just say if you get a rational number, leave it as a rational number. Just make sure you go to lowest terms. This one also has a fraction. I have 2/3 of m plus 7 is equal to 1. Now, you have 2 choices right now of what you want to do first. Do you want to clear the fraction, or do you first want to combine the 7 and the 1? And I think it might be easier to go ahead and put that 7 and the 1 together to have one less thing to deal with. So I'm just going to subtract 7 from both sides. So I have 2/3 of m is equal to 1 minus 7 is negative 6. I'm going to multiply both sides by 3. That's going to clear the fraction. So the 3 cancels. I have 2m is equal to negative 6 times 3 is negative 18. Now I want to get rid of the 2, so I divide both sides by 2, and that says m is equal to negative 9. So here's one with more fractions. I have 1/3 of x plus 1/2 is equal to negative 4 times 2/3 of x plus 8. So as I'm looking at this, I can see I have a 3 in the denominator, a 2 in the denominator, so eventually I would like to clear those. Before I do that, I'm going to deal with this negative 4, and I am going to distribute it. So I have 1/3 of x plus 1/2 is equal to negative 4 times 2 is negative 8/3 of x. Then negative 4 times 8 is negative 32. Now I'm ready to clear the fraction. So what I look for is anything in the denominator. I look for the greatest common factor. And for 3 and 2, it would be 6. So I'm going to multiply everything by 6. So I'll start it this way. Then I'm going to multiply by 6 on the left. I'm going to multiply by 6 on the right. I'm going to do that individually. 6 times 1/3 of x plus 6 times 1/2. And then 6 times negative 8/3 of x plus 6 times negative 32. So I'm going to cancel. 3 goes into 6 2 times. 2 goes into 6 3 times. 3 goes into 6 2 times. There's all my fractions. So let's make that look better because it's kind of messy right now. So 2 times x, there's 2x. Then I have plus 3. 2 times negative 8 is negative 16x. And then 6 times negative 32 is negative 192. Now I'm going to move this 3 over to the right. So subtract 3 from both sides. I have 2x equals negative 16 plus negative 195. Now I have 2x on the left. I have negative 16x plus negative 195 on the right. Let's combine the x's. I'm going to add 16x to both sides. 2 and 16 gives me 18x. This is negative 195. And I'm going to write that on the side. So 18x over 18 is negative 195 over 18. Looking at the negative 195 over 18, I say, well, could I reduce that? And when I look at it, negative 195 is divisible by 3. 18 is also divisible by 3. So I end up with negative 65 over 6. The next one also has rationals, but what's different is the denominator is the variable. So as we're dealing with these, we do want to pay attention to, we'll have excluded values that we couldn't have. Like in this one, I couldn't have an x value of 0 because I'm not allowed to divide by 0. So I will kind of look back just a little to make sure any of my answers aren't excluded from what they're allowed to be. I'm going to treat this the same way I did the last couple, where I'm going to clear the fraction. And how am I going to do it? It's going to be by multiplication. So I look at x and I look at 2x and I think, well, if I multiply everything by 2x, I can clear the denominator. So the left side multiplied by 2x, the right side multiplied by 2x. And I really do like to go ahead and distribute that. So I'm going to keep the 2x with 4 over x. And I'm going to say 2x needs to multiply by negative 3 over 2x. 2x needs to multiply by 8. So the x cancels. Then the 2x cancels. So I can look at what I have left. I have 2 times 4 is 8. I have negative 3. And then 2x times 8 is 16x. Just to be kind of lazy, I'm going to go ahead and leave the 16x on the right and move that 3 over to the left. 8 and 3 is 11. This is 16x. So I'm going to divide by 16, which says x is equal to 11 over 16. The only thing I'm checking is, can I use that value? So 11 over 16 is fine in the denominator. It doesn't force me to divide by 0, which we know we're not allowed to do. So this next one, very similar. I also have an x in the denominator that I want to get rid of, so I'm thinking I can't have 0 again. I also see a 3 in the denominator, so I'm going to multiply by 3x. And let's just go ahead and do that individually this time. So 3x times x plus 8 over x minus 3x times 2 over 3. And that's going to be 3x times negative 4 over x. I always say, take your time. There's a lot of little steps here. Make sure you don't miss a negative sign or something that will throw off your answer. So let's cancel. The x cancels from the first term. The 3 cancels from our second term. So that x canceled the x. So let's look at what we have left. We have 3 times x plus 8. That's 3x plus 24. Minus, and don't lose this minus sign here, I have 2x. And then I have 3 times negative 4, which is negative 12. So let's combine like terms. I have a 3x minus a 2x, which is x, plus 24, is negative 12. So I just have this last step of subtracting 24 from both sides. Here's my solution. X is negative 36. Again, check back. You can put negative 36 in the denominator, so we're good to go to the next one. To show you it doesn't matter what variable we have, I put in a y, and this time I did y plus 2. So instead of just having a single variable, I have like this little expression. I'm still going to use that to multiply. So everywhere here, I'm going to multiply by y plus 2. So y plus 2 over 4 times y plus 2 plus 3 times y plus 2 equals y plus 2 times 5 over y plus 2. So each of the terms, everybody got a y plus 2. Now I go to cancel. Y plus 2 cancels in the first term. The second term is fine. And then on the right, it also cancels. So this is going to get smaller really quick. Now I have 4. 3 times y plus 2 is 3y plus 6. And that's equal to 5. I'm going to put the 4 and the 6 together. So I have 3y plus 10 equals 5. We'll subtract 10. So now 3y is negative 5. And our last step is divide by 3. So here's my answer. Y is negative 5 over 3. When I plug it back in, or when I'm thinking about plugging it back in, I think, can I put negative 5/3 plus 2? And absolutely I can. All I'm concerned about is, does that give me 0? And it doesn't. If my answer had been negative 2, I would have said, oh, that's a problem. I can't have negative 2. But as long as I don't get an answer of negative 2, I'm good to move on. So let's do one more. This time I have 8 over x plus 3 minus 3 over 4 is equal to 3 over 2x plus 6. So the first thing I want to do is look at the denominator and see what I have. I have an x plus 3, I have 4, and I have 2x plus 6. What I want to do with this 2x plus 6 is factor out a 2 to show that it really has that x plus 3 in there as well. So when I'm looking for this kind of common denominator that I want to clear, I can see that I have an x plus 3, and it's there twice. I have a 4, and I have a 2. So 2 goes into 4, I cannot worry about that 2, and I can think I can multiply by 4 times x plus 3, and that's going to clear the whole denominator. So I'm going to multiply 4 times x plus 3 times the first term, 8 over x plus 3. Then I'm going to multiply 4 times x plus 3 times my second term, 3 over 4. And then 4 times x plus 3 times my last term, 3 over 2x plus 6. So in the first term, the x plus 3 cancels. 4 times 8 is 32. In the second term, the 4 cancels. When I multiply out, I want to think of this being a negative 3. That way I retain the sign and I distribute it to the x plus 3. So negative 3 times x is minus 3x. Negative 3 times 3 is minus 9. On the right side, I'm going to kind of rewrite this underneath as 2 times x plus 3 so I can see the factors there. The x plus 3 cancels x plus 3. 2 goes into 4. 2 times 3 is 6. Now I want to condense the left side. So 32 minus 9 is 23. Minus 3x is equal to 6. I want to bring the 23 over, so I have negative 3x. 6 minus 23 is negative 17. Then I divide by negative 3 on both sides. I get x is equal to 17 over 3. So I hope that gets you started with linear equations in one variable. See you in the next video.